and let's get started then. So I did actually do a virtual contest before. Like I think I will give couple of more minutes for folks to join in. So yeah, I did try to do a virtual contest here, and I think the time was around 45 minutes or so, where I had three WAs or something like that. And yeah, I think for more updates, you can follow my Telegram channel as well, where I will regularly post whenever I go live. Like, and yeah, I think I'm setting up in the channel. So I think let's get started now. Okay, so first problem was a bit troll problem. It says you are given an an array nums of n distinct integer. You want to construct an array nums 2 of length n such that all the elements in number are either odd or all even. For each index I, you must choose exactly one of the following in any order. Either set it to the same number or subtract it, or set nums2 equal to nums1 minus nums j for any index j not equal to I. Return true if it's possible to construct such an array, otherwise return false. Like this is a bit troll problem because like the answer is always true. So I think we can try to see like why exactly it's true, but yeah, that's where we are. So like for example, if all numbers are odd, then the answer is definitely true, right? If all numbers are even, then also the answer is always true. Otherwise, you have at least one odd and at least one even, right? And one even. At least one odd, one even. The idea is you can choose j to be this odd number. So what you can do is num I is odd, keep it same, If num I is even, then do the second operation, which is this will be even, this will be odd, and even minus odd is always odd. So this way you can get all the number can, you can make all the number odd over here. So that's why the answer is it's always possible. And all you have to do over here is print to, like, you don't have to create such an array over here. So any questions on the first problem? Before you jump on to the next problem? Okay, let's move on to the next problem then. Again, it says you are given the same setup, just that we can do num I minus num j only if num I minus num j is greater than equal to 1. Earlier we could choose num j arbitrarily, now we cannot do that. So now again the problem setup remains the same. If all numbers are odd, then we should return true. If all numbers are even, then we should return true. Otherwise, you see we have num I minus num j, where num I minus j is greater than equal to 1. So like the catch here is, like, let's see when num j is the smallest number. Then you can never change it, because you will not find any number which is where the difference is greater than equal to 1, because this value is always greater than equal to minimum. So this difference will always be less than equal to 0. So this means, like this, because we cannot change the smallest number at any point of time, this fixes what we can do. Like, if smallest number is odd, then all the numbers should be odd. If smallest is even, then all the numbers should be even. Then all numbers should be odd. And now let's see like what different odd minus even combinations exist. Odd minus odd can give you even. Even minus odd gives you odd. Even minus even gives you even. And odd minus odd also gives us odd. Now if smallest number is odd, then we can choose not to do anything with odd numbers. Keep same. And whenever you encounter an even, you subtract smallest number from it to make it odd. So like this again ensures that you can make all the numbers odd. Like the same thing, if the number is odd, keep it same. If the number is even, do num I minus num j, where num j is the smallest number. And if your smallest number is even, then like your like the sorted array would look something like this. Like there would be some set of even numbers. Or essentially, let's look at like among all the numbers, find the smallest odd number. If you have a smallest odd number, then only thing you can do is you can choose j, but all of those j would be even numbers. So you can never change. So you can never change like the smallest odd number to an even number. That's why the answer would be false in this case. And I think this is where like the whole idea is. Okay, you should look at the smallest number, and if it's even, then you cannot do anything. If it's odd, then like you can use it to subtract all the numbers. So the solution briefly looks like this. We maintain odd count. We maintain even count, and we try to find min value. We can update the minimum value with the current value. If number is odd, we got +1 for odd. If the number is even, We do a plus one for even. If the number of odd numbers is equal to the array length, we return true. If the number of even numbers is equal to the length of array, we return true. Otherwise, if minimum value is odd, we return true. Otherwise, we return false. So the only false case is when you have both odd and even numbers, and the smallest number is even. Any questions so far? Okay, this is passes. Any questions on this one before we jump on to the next problem? I think the remaining two problems are quite hard. Okay, I think let's jump on to the next problem then. You are given an array nums and a target. You may remove any number of elements from nums, possibly 0. Return the minimum number of removals required so that bitwise or of all the remaining elements is equal to target. If it's impossible to achieve target, return -1. The bitwise OR of empty array is 0. So the problem statement essentially says we are given an array A and a target value. We have to remove some elements from this array. such that whatever remains, the XOR of them is equal to target. Like in general, this problem is quite hard to solve, but in this case, like you should always pay attention to the constraints in the problem, like which are written at quite the bottom. It says that like the length of the array is less than equal to 40, and AI comma target is less than equal to 10 to the power 4. And this problem essentially has two solutions: meet in the middle, which I will skip for today, and dynamic programming. And the other caveat is like even though this solution allows it, you can solve using meet in the middle, even if AI comma target was quite high. Say 10 to the power 9 or 10 to the power 18. And n less than equal to 40. And if you go via DP, you can even solve this problem for harder constraint, like let's say n less than equal to 1000, and AI comma target less than equal to 1000. So these are the two versions for this problem. So I think like the idea for DP would be as follows. Like we are at index I. Current XOR is this. What is the minimum number of elements we have to remove between the rest of the elements to get the required target? Minimum elements to remove. Like let's say we have fixed the numbers from A1 up to AI minus 1. And the ask is what we can do from I up to n to get the required target XOR. And overall, I think this would run it into the time complexity of order of n into like the maximum AI, which is around 10 to the power 4. We can make two decisions. From DPI, comma current or if we don't take the current element, then we move to state DP. Current zone, and we do a plus one for whatever answer we get from the remaining part. Or if we don't do anything, like if we keep the remain current element, then you will move to DP of I plus one, comma your current zone would also change. It should be AI of whatever running zone you have. So I think overall this is the idea for this problem. Any questions on the problem statement first before we jump on to coding? Does anyone know like how do I increase the width? I will try to code it in Python first. If it doesn't works out, then I will jump on to three. Like I felt that like the time limit was quite high. Let's maintain some infinity. If we have reached to the last, if current or is target, then we can reach this goal return 0. Otherwise, we have not reached the resultant target, so we return infinity here. Otherwise, we look at the current value. We return minimum of following two edge cases. We remove the current element or we take the current element and new XOR becomes current XOR current one. Now our result would be dp of 0 comma 0. If result is greater than equal to infinity, then we return -1. It's impossible to reach this target. Otherwise, we return less, whatever minimum value we could get. Like the only case is I'm not sure if it would get TLE or not. Like in Python, my solution like that I tried earlier was getting TLE. Okay, this passed all the test cases quite smoothly. So, any questions, anyone on this problem before we jump on to the last problem for today? I think couple of minutes and then we will jump on to the last problem for today. So let's read the last problem. It says you are given an array nums. A subarray is good if bitwise OR of all of its element is equal to the at least one element present in the subarray. Return the number of good subarrays in nums. A subarray is continuous non-empty sequence of elements within an array. The bitwise OR of two element numbers A and B is denoted by A is or B, like this one. So what we have been given is, like, I haven't checked the constraint, but I think it's worth checking it. So it says the length of numbers is up to 10 to the power 5 and the numbers are up to 10 to the power 9. So what we have been given is we have an array A. We have to count number of subarrays. L to R, where XOR of up to AR is present in the elements from L to R. We have to count number of such subarrays. Like how does a brute force solution will look like? Like a brute force solution would look like this, right? We start with the first element. We keep list of all possible jaws and the like essentially we maintain list of all the jaws. Like we process numbers one by one. When we are at number AI, keep list of all suffix jaws. Basically, we keep like list of all possible jaws we can get from, let's say, AL up to AI for all possible values of the jaws we can get. And one crucial observation is whenever you have two numbers x or y, let's say we have x, we have y, then x or y will always be equal to x and it will always be equal to y. The idea is that we can look at the truth table of all the bits for OR operator. OR of 0 and 0 bit is 0. 0, 1 is 1. 1, 0 is 1. 1, 1 is also 1. So you can see in this table like the number on this side is more than for each of the individual bits here. So this gives us like the whenever you maintain a running sum and if you add some elements to it, like basically the OR will keep on increasing. And one more thing is like if any of the bits is 1, then the OR is 1. So the OR is increasing, and every time when the OR increases, it changes at least one bit from 0 to 1. Let's say our running number looks like this. Then when we add one more element to it, and let's say if the new element is like this, let's say this is A3, like this is OR of all the numbers from fourth index up to I. Then what is the news or we will get? Three up to I would be like OR of these bits individually, which is again 1, 0, 1, 1, 0. And let's say A2 looks like this. OR of 2 up to I would be this 1, 1, 1, 0, 1. Like you can notice the pattern here. All the bits that were 1 here, they remained 1 here. And some new bits also became 1. Like this is the binary notation of the numbers. Now let's say A1 looks like this. Then OR of numbers, 1 up till I would become like this. This would be 1. This would be 1. This would be 1. This 0 has changed into 1 because this one came in. This one became 1. So like bit never gets, like every single time when you are adding number, ones remain 1 and that time 0 becomes 1. And like our number is up to 10 to the power 9. So how many bits we have? 10 to the power 9 has around 30 bits. So when you are start from a number, if you keep increasing one number one by one, go to the left, your OR can only increase 30 times. When some bits will become, every bit will change from 0 to 1 at some point in time, but 1 will never change back to 0. So this is the whole idea, that number of different possible JAWs you will get would be at max 30. And like this gives us some confidence that some brute force in the form where we maintain the all possible JAWs, we add one more number, try to update that list, etc., should kind of work here. Like this is first part of this problem. So what we can do is, we have numbers from 1 up to AI. We maintain all the possible subarrays that ends at AI. What is their XOR? And then we can go back and see if for each possible element at which place you have seen it recently and try to count the numbers based on it. And then you move to the next number. So I think I will probably start coding now. We maintain a dictionary. Now let's first try to figure out new ranges. Range. This is your previous one. Now update this new or with the previous ones. If this doesn't exist at all, then it's a no-brainer. Whatever value you have got would be the range here. Otherwise, let's find old range, or let's call it other range, like basically left and right endpoint here, or like new left endpoint would be old left endpoint, other left endpoint, and current left endpoint. New right endpoint would be maximum of, and we update like the range endpoint as new range. What I have done for the sake of simplicity is, let's say we already had a range 3 up to 7. Basically, the left endpoint for 3 up to 7 has OR of 10. And let's say whenever the left endpoint is from 3 to 13 also, then also like the OR is 10. And like we have AR somewhere here, which is something later. Then what I am claiming is whenever the left endpoint is between 3 to 13, like for everything here, the OR would be 10. It doesn't hold for regular numbers, but in case of OR, like because we see like if the whenever the left endpoint from 1 to 13, like we had around 10 OR, and when we have 3 to 7 as well, it means like no value change from 0 to 1 whenever the left endpoint is even between 7 to 8 as well. Or I think using left and right, it would be better new lower bound and new upper bound. New low left, new high left. I think this is the better terminology here. And one thing that we can also do over here is we can just keep the current number and it's all would be equal to the current element here. And later on, before we wrap this loop, we update our range with whatever new range we got here. Now we can iterate over this loop as well. Whatever new range or we got, I think it will make sense if I use Sublime text or something. Then what we need is we need to find where, like, because like this is the left endpoint and the like lower bound and upper bound of the left endpoint where we would have current value of zor. And what we need is like, does this value exist somewhere in this array? If yes, then we count those left endpoints. So for that, what I will keep is I will also keep a dictionary of last seen, because I need the nearest maximum index where like all the current values exist. If current or exists in the array itself first, and if last seen of this value is between the new no left, then I will add this complete range in my answer. Like this is the possible endpoint. Like here the idea is, then AL to R is good subarray. And at last, when we are done with everything, we return whatever answer we got. And like this is the solution for this problem. So overall, I think this wraps up the stream for today. Any questions, anyone, whether related to this contest or something else? This should be well. This should be edits. Okay, we need to even add answer. Okay, I think this wraps up all the four problems for today. Any questions, anyone? Like, don't forget to join in the Telegram channel. And yeah, I think I am planning to keep more lead code streams. And yeah, I think I will probably put VOD on my YouTube channel. And let me know if anyone else any other questions before we wrap it up for today. So thanks everyone for tuning in today. And yeah, I think let me know if you want me to have similar streams more. And yeah, and I think this is where we are. And thanks everyone for joining in today. And let me know if you have any questions. I will have a couple of more minutes and then I will wrap it up. So yeah, thanks everyone for joining today.